working on a VCAA 2011 Exam 2, Section 2, Question 3. So for Part A, I 95% got this right, and it was just asking for what is the derivative of f of x is equal to 4x to the power of 3 plus 5x minus 9. So this is something that you would have learnt in Unit 1 and 2 and revised in Unit 3 and 4. So to do this, we're going to use the power rule. So the power will be taken out the front. So 3 times 4 equals 12. So I've got 12x and 1 less power, 2. Then I've got 5x, so that will turn into 5 plus 5 and minus 9 it goes. So then for the next part, for II, 47% got this correct. So it says explain why the derivative of x is equal to or greater than 5 for all x values. So we need to understand what this 12x squared plus 5 means. So first thing I'm thinking about is what is our derivative mean? It's talking about the gradient, and our gradient for x squared would be would be greater than 0. If I use that in relation to my 12x squared plus 5, we're really saying 12x squared plus 5 is equal to or greater than 5, and the 5's cancel out, saying 12x squared is equal to or greater than 5. And that is for all x values. Moving on to the next part. So part B, people found a lot more challenging. So for BI, only 9% of people were able to solve this. And for BII, only it's 20% were able to solve this. So let's go through this. The cubic function is defined by P with a domain of all real numbers, and is graphed with all real numbers. P of x is equal to ax to the power of 3 plus bx squared plus cx plus k. So it's first asking us if P has m stationary points, what possible values can m have? So in terms of stationary points, straight away we're looking at the derivative. So I'm just going to I'll find the derivatives. I'll take the 3 out the front, and that will give me 3ax squared. I'll take the power of 2, and that'll be 2px, and then the x is cancelled, and I lose the k. This is what I get at the moment. Now, at the moment, the next step that I can do is I'll make that equal to 0. Now, this helps me because if I'm looking at this, so I've got a quadratic here, and a quadratic means that I could have one solution, two solutions, or 0 solutions. So that will give me straight away 1, 2, 0, 1 or 2 solutions to equal 0. And that tells me how many times I have a stationary point with a gradient of 0. That's the first step that I need to take. The second part for II, and this part here is 20% got it right, says if P has an inverse function, what possible values can M have? So if we're thinking about an inverse function, it needs to be a one-to-one function, which means we are going to be having it in terms of either with a stationary point, so that's a terrible graph, or with no spot where we got a stationary point. So that means if we're talking about stationary points, it's either a 0 or a 1. Actually, before the flashing of the screen, I've got no idea what's causing that, and I just didn't want to restart this video. Okay, so now we're going to look at. So for CI, it says the cubic function Q is defined by Q is described for all real numbers. The graphing all real numbers Q of x is equal to 3 minus 2x to the power of 3. So for this, 76% got this correct for I. So it says write down an expression for the inverse of Q. The first thing I think about when we're talking about the inverse is I switch my x and y's around. So that gives me x is equal to 3 take away 2y to the power of 3. I again will solve for y, so I will take away 3 and I get x take away 3 is equal to negative 2y to the power of 3. I will then divide by negative 2. And then finally, I will cube root. So if I'm going to cube root, it'll be my inverse is equal to cube root of x take away 3 over negative 2. If I would like to make that a bit more easier to read, I'll then use this, and I'll just get rid of this negative and change my negatives on the top, and that means I'll have 3 take away x over 2. So then I only 60% got full marks for this. So it says determine the coordinates of the points of intersection of the graph y equals qx and y is equal to the inverse of qx. So the first thing I need to think about is all I care about is my first function, which is a lot easier to read, which is q of x is equal to 3 minus 2x to the power of 3, and the inverse is always going to be on this line. That means straight away I can substitute x into as y, and I'm going to be given x is equal to 3 take away 2x to the power of 3. Now for this, all I'm going to get you to do is throw this into the calculator and solve. If you do that, you will find out that x equals 1, which means y equals 1, and that gives me the point x1, y1. So we've got the cubic function g is defined by g with the domain of real numbers is going to be graphed with all real numbers for g of x is equal to x to the power of 3 plus 2x squared plus cx plus k, and all real numbers. So for I here, we had only 30% of people get full marks. So if G has exactly one stationary point, find the value of C. So as soon as we're talking about stationary points, the first thing we need to do is find the derivative and find when the gradient is 0. So straight away here, I've got x to the power of 3. So that will then give me 3x squared. 2x squared turns into 4x plus c, and the k is cancelled. So now I'm going to look at, I'm wanting to factorize this and complete the square. So straight away, what I'm going to do is I'm just going to factor out the 3 here, because when it says one stationary point, that means it only has to be touching the x-axis. So that will give me x squared plus 4 over 3x plus c. If I'm completing the square, then I'm going to look at half b, which will be 2/3. Okay, so now I'm just going to simplify this and put it into the complete square form. That will give me x plus 2 over 3. Need extra brackets here, make sure you do that. Take away 2 over 3 squared. I can simplify that. 2 squared is 4. 3 squared is 9. Plus c. Now I can go one step further and I can simplify that by going 3 times 4 equals 12. 12 over 9 gives me 4 over 3. So now, based on this, to cancel out that 4 over 3, I'm going to have my c value be 4 over 3. So that means I will have one solution. Let's look at II. So for 2, we've got if this stationary point occurs at a point of intersection of y is equal to g of x and y is equal to the inverse of x, find the value of k. So the first thing we need to think about is what is our derivative? So our derivative at the moment is 3x squared plus 4x. We did have a c value, but we know what that c value is now. So we got 4 over 3. That's the first thing we need to think about. The second thing we need to know is what are we wanting for the turning point? We know we are wanting x is equal to negative 2 over 3 because we've got that on this first part right here. That is where the turning point is, where it's going to have one point of intersection. Okay, so that's the next part that we know. So all I'm going to do is I'm just going to want to substitute that into my function. And that is going to then give me, so substitute now the turning point, because that's what we're wanting. We're wanting the turning point to be where they intersect. And with the inverse, which means our y, this is going to give us negative 2 over 3 as well. So if we substitute that as an x and this is our y value in, it is going to give us our k value. And our k value then is going to be negative 10 over 27.